In this example, we're going to be solving this application log function. And so here we're given this model function already, S of t, which is our sales of a new product. And that can be approximated by this model right here, 100 plus 30 log base 3 of the quantity 2t plus 1, where t represents the number of years after the product is introduced. So these three questions go as follows. What were the sales to the nearest unit after 1 year? So after the product was in for a year, what would the sales be? What were the sales in 13 years? So after 13 years, and then graphing it. So really, Desmos does this very well, where you can just go ahead, plug in our function. By the way, Desmos doesn't do like S of t yet. I think they're working on that, at least when this video is made, but probably here very shortly they'll have it already up and ready. So I had to use x as the attritional variable. So if I want to find what was after 1 year, well that means I'm just going to do S of 1, right? And so that means that's going to be 130. Well, 130 what? 130,000, right? This is sales in thousands of units. So that's going to be 130,000. So after 1 year, that's what their approximate sale is. And what about in 13 years? And before we put it on there, if you just want to kind of make an estimate, you would think that after 13 years, it would be a pretty big number. But check out this number right here. It's only at 130. And that's because when we graph it, look at what happens here, right? By knowing what a log function looks like, we know that it's going to tailor off. So that it's kind of like you had a banging year, right? After year 1. And then things didn't go as swell. I don't want to say as swell, but maybe it didn't boom as much, right? It didn't grow as much. And that's because log functions don't grow rapidly after a few years, if you will, right here. So, and that's it. So we also graphed it as well.